Hi everyone. I'd like to tie together now a couple of ideas. One is the idea of trying to make a function continuous, and the other is the idea of trying to make it also be differentiable. So if you'll remember, we looked at piecewise functions before, and in order to make them continuous, we had to make sure that different pieces matched up. And now the idea will be not only do we need pieces to match up, but we need them to match up with the exact same slope. So let's talk about the continuity of this one first, and then as we get into differentiability, I'll try and explain with a picture what I mean by that. Okay, so if the function is not continuous, it's automatically not differentiable. So I often will look at the continuous part first and see if I can get anywhere with that. So I can see that I'm cutting the two pieces off at x equals 2 and then hopefully gluing them together. So I'm really hoping that at x equals 2, these will meet up nicely. And right now, my biggest concern about that is the fact that this one looks like it could have a vertical asymptote when x equals 2. The bottom is 0. So the very first thing I need to deal with here is making sure that's not a vertical asymptote at the x value I'm trying to hook them up at. So I want to make sure that this is in fact a 0 over 0 when x is 2. So the 2 minus 2 gives me my 0 on the bottom. I have a times 2 minus 4 on the top. If I want that to be 0, I need a to be 2, so that I have 2 times 2 minus 4. So it looks like a needs to be 2 for this thing to be continuous. So now I'm looking at g of x is equal to, okay, so I take my 2x minus 4 over my x minus 2, and on the top I can factor the 2 out, and I actually am just left with y equals 2. So if a equals 2, it makes the function just a constant function, y equals 2, except there's a hole at x equals 2, but I don't really care because I'm cutting it off just shy of that anyways. So I get a constant function y equals 2 whenever my x value is less than 2. And now I have to decide what in the world to do with my b. And all I know is that the thing I'm still trying to make work out, b, is the two have to meet up, and they have to meet up in a way that makes them have the same slope at their meeting point. So I'm gonna, let's see, I'm gonna sneak over on this side. Okay, so 2, 2. So this is what I know I have. I know I have a horizontal line at y equals 2 that cuts off at x equals 2 with an open circle. So again, really two things here. One is I need to make this meet up, and then I'm also hoping to make the slopes match up. So what I see right now is that I have a parabola that opens up, and I'm getting the opportunity to shift it up 2 for sure. And then I can shift it left or right however much I want. That's what the b does. A positive b will shift me left, and a negative b will shift me right. So I know that that vertex has a y coordinate 2, and its x coordinate will end up being negative b. Okay, so actually I think continuity might force the issue here, but we can still talk about the differentiability. So if I want this piece to meet up with what I've got here, I need to shift its vertex to this point. Its vertex is its lowest point, and it will just hit where I want it to. So if I make b equal to negative 2, that will mean I'm shifting to the right 2, and that vertex will fall right into the point that I'm hoping it will fall into. And then this graph will head off looking like half a parabola. So that got my continuity, but you want to think about the differentiability as well. So this horizontal line is absolutely differentiable everywhere, as is this piece of a parabola. So it's really just about what's happening at this point. And the question is, do I have a sharp corner or not? Do these things connect in a smooth way so that their slopes are the same? And I actually get that one kind of for free here. I don't have to do a lot of work to figure that out because I know the slope all the way along this horizontal line is 0. And I also know that the slope right at the vertex of a parabola is 0. So I got it. This should be continuous and differentiable. Okay, so let's look at one more. I think I made this one a little trickier on the differentiability. So now I have a quadratic. Let's see. And I'm cutting it off at -2. Let me think about that. Is that really what I want? 4. Sure, I'm good with that. Okay, so I have a parabola that's shifted up 4 and it's upside down. So typically I would see, move that just a little, this. That would be my parabola. But I'm cutting it off at x equals -2, which if you look at this, 4 minus x squared, when you plug in -2, you get 4 minus 4. That's one of its intercepts. So I'm cutting it off at -2 with an open circle, and I'm only keeping the stuff to the left. So I have this tail end of a parabola headed down on the left-hand side. And I am supposed to make a line meet up with that. And I get to determine everything about the line, both its slope and its intercept. So I want to make the line meet up with that in a way that not only does it hit this point exactly, but it also matches the slope of my quadratic right there. So in this case, I don't think I can go about picking a b value until I've figured out the slope, because I won't know where it needs to hit the y-axis until I know how steep it needs to be. So I'm going to work on the slope part first, and the slope part has to come from the quadratic. We need the slopes to be the same. So we need to figure out the derivative. How am I going to write this? Derivative, use this notation on you a little bit since there's not a ton of it early on in this class, of 4 minus x squared, which is going to be the limit as h approaches 0. And you could do this, we're really only interested in what's happening at -2, so you could plug the -2 in up front or not. Since we're working on derivative function, I'll go ahead and do this without plugging the -2 in. So first we're supposed to plug in x plus h, and then we're supposed to plug in plain old x, a little bit scrunched. Okay, so there's what my derivative function will look like for the parabola, which is going to equal the limit as h approaches 0 of, let's see, okay, so we have a 4 minus x plus h squared is x squared plus 2xh plus h squared minus 4 plus x squared. Make sure that negative sign distributes. And we can cross out the 4's right now. So I'm going to go ahead and do it. This 4 is gone and this 4 is gone. So we'll end up with h goes to 0. A negative x squared, so distribute your minus through, minus a 2xh minus an h squared, and then we still have that plus x squared at the end. Okay, so now we can get rid of x squared, so we have a plus and a minus, and then we can factor out the h. So I have the limit as h approaches 0 of h times negative 2x minus h over h. And the h's go away, and then as h goes to 0, this will just drop off, and I'll be left with my negative 2x. So if I want to find the slope at a point on 4 minus x squared, the slope of a tangent line, I would just multiply whatever my x coordinate is by -2, which means the slope right here, let me just pick a different color. The slope of this tangent line, if we hadn't cut the function off, would be -2 times -2, which is +4. So if we want this, we basically want this line to be the tangent line. So this tells me that A, yes, A has to equal 4. So now I have a line, and I know its slope is 4. So I've got 4x plus b. And then I want to make sure that I choose the right y-intercept to make it hit the point -2, 0. -2, 0. So I'm going to, I can do it either way. If we want to use point slope form, if I can remember the names of these things. It's actually pretty easy. I get y minus 0 equals m, which is 4, times x minus negative 2, which is an x plus 2. So y has to equal 4x plus 8, which means my b has to equal 8. So basically this problem, it was presented in a funny way, but it was basically a find the equation of the tangent line problem. If we wanted a linear function to meet up with a quadratic function in a way that made the whole thing continuous and differentiable, that linear function had to be the tangent line. That's the only way the slopes will match and the points will match. All right, thanks for watching.